Thank you. Hello, everyone. How's it going? You don't seem too tired. Now, I'll admit that the positioning of this talk is not ideal. First of all, it's the third talk of the evening. Not great. And I'm the only thing standing between you guys and some food and drink, which is even worse. And it's in English. Okay, so 3 factors here that are not playing in my favor, but I'll try and make this as painless as possible. Thank God that we've got a fascinating topic to talk about, logs. More specifically, we're going to be talking about logging and monitoring a Dockerized environment with the ELK stack, or as it's been renamed these days, Elasticsearch, Elasticsearch, Logstash, Kibana. But I'd like to start with a true story. Anybody recognize what this is? SKB Rides the Rocket. I'll give you a clue. It's not the name of a new Disney movie. Okay, so SKB Rides the Rocket is a Linux kernel bug, specifically Debian 6, results in packet loss. And it was also a huge headache for our development team, who for over a week couldn't understand why some of our customers kept on complaining about connectivity issues with one of our services. Until, finally, they came across this log message. Take a close look at that log message. Not very descriptive, is it? Nothing telling us what exactly is happening behind the scenes, no mention of an error or a bug. Terrible. So the big question is how, in a production environment generating literally millions of log messages a day, how did our team finally come across this log message, and how did they troubleshoot the issue? And the answer is a combination, okay? Combination of centralized logging using the ELK stack and a touch of machine learning. And if I do my job correctly, hopefully you guys will understand at least the potential of using that combination in logging a distributed environment. So my name is Daniel. I'm an evangelist at Logs.io. If you've no idea what an evangelist is, don't worry about it. You're not the only one. Basically, I get paid to talk and write. I write a lot about techie stuff, so Docker, the ELK stack, AWS, DevOps, stuff like that. I've got a couple of professional sins. So one of them is Twitter. I virtually live on Twitter. So if I haven't ruined your impression of me yet, feel free to follow me at that handle. And yes, there's a story behind that handle. So if anybody wants to ask me about it later on, feel free. My second professional sin is organizing things. I'm an organizer of a couple of meetups back home. I'm also an organizer of the DevOpsDays Tel Aviv. 1 minute, I promise, on Logs.io. They're paying the bills after all, so bear with me. Logs.io is a log analysis company. Okay, we provide the ELK stack as an end-to-end service on the cloud. Okay, as part of that service, we take care of the entire logging pipeline, collecting the data from the different data sources, parsing it, indexing it, archiving it, securing it, etc. On top of the ELK stack, we've added some features that are missing in the open source world. So, for example, a built-in alerting mechanism so you can get notified in real time, either by email or Slack, PagerDuty, whatever weapon of choice you want to use. ELK apps, which is a library of pre-made dashboards and visualizations for different log types, S3 archiving, audit trail, live tail, and I can go on and on and on. Security, okay, we put a huge focus on security. We're basically the only ELK stack out there that is SOC 2 compliant, HIPAA compliant, PCI level 1 compliant. We are ISO 27001, and most importantly, we also GDPR ready. Now, on top of all of this is a layer of artificial intelligence and machine learning, and hopefully we'll have time to get a taste of that later on. So, what are we going to be talking about tonight? I'm going to bore you with some logging definitions, okay? What logs are, why we need them, why we use them, etc., specifically in a Docker environment. We're going to take a look at some of the challenges, okay? Some of the intrinsic challenges in Docker that make logging such a headache. We're going to take a look at some of the solutions that most of us here might be or probably using. We're going to then take a look at how the ELK stack helps solve these challenges. We're going to take a look at how machine learning complements the ELK stack and centralized logging. And hopefully, we'll have time for some questions after a short, brief demo. Right, so let's get started. What are logs? Anybody wonder about that philosophical question before? Yeah, I can see the rolling eyes. So basically, if we ask Google, we get a couple of interesting answers. So, no. Logs are not pieces of wood, at least in software development. But the second answer here is getting closer to the mark. So like a ship's log and like an airplane's log, logs in software development are basically streams, okay, of aggregated and time-ordered events collected from the output of running processes in your environment. And like a ship's log, like an airplane's log, when your services crashes, when your containers crash, the first place you're going to take a look at are those logs. Why? Well, if structured correctly, they could contain a wealth of information about what's going on. Okay, when it happened, why it happened, what happened, and probably more importantly, who's to blame. And those are the famous 5 W's that people talk about when theorizing about logging. And yes, people do theorize about logging. You'll be surprised. So these days, any device with software on it generates logs. Okay, it's not just our containers or our Docker hosts. It's sensors. It's smart TVs. My brother brought a drone a couple of months ago, and just for the heck of it, I hooked it up to a Raspberry Pi and then installed an elk stack, a vanilla installation of the elk stack. You wouldn't believe the amount of log data a simple drone that costs $50 on Amazon generates. So any device generates log data. And naturally, as developers, we'll be using log data for, well, development and troubleshooting applications, monitoring them, but more and more use cases for using log data, okay? Not a week goes by where Logs.io, at least, we learn about a new use case that people are using logs for. So it could be BI, it could be marketing, it could be, it is security, et cetera, et cetera. So in the context of Docker, okay, let's take a look at some of examples of the types of log data that we can extract from our environment. So, of course, the first case, we've got our application or the services themselves, right? So these kind of logs will typically contain a timestamp, okay, telling us when the event occurred. We'll have some kind of request ID or service ID that'll help us trace the request across the different data sources, okay, as the request is processed across the different components. We'll have some kind of severity indication telling us how important the event is, hopefully. And then we'll have a meaningful message, okay, telling us what actually transpired. In this case, you're looking at an example of one of our Logs.io services, in this case, in charge of collecting the data from our customers. We call these listeners. Very original, I know. So in this case, one of the appenders is reporting that just cleaned up after itself. Now, depending on the service itself, you can also use logs to collect metrics. So in this case, it's that same listener service telling us, reporting to us that a specific customer sent us a specific amount of data. And of course, you've got a variety of different performance metrics that you can collect from your Docker hosts and from your containers. So memory usage, CPU usage, network usage, etc. So taken together, these 3 different types of information can give you a nice general picture of how your Docker environment's performing. Let's take a look at some of the challenges, okay, that we deal with when trying to log a Docker environment. So in the first case, we've got to remember that in essence, containers are extremely dynamic in nature, always on the move. At any given time, we can stop a container, restart it, kill it, remove it, etc., which makes it extremely difficult to persist log data. Okay, so in a way, one of the reasons why we like to use containers in the first place, in the context of logging, is a huge, huge headache. Okay, this is the transiency issue. The last Datadog survey that I read about container usage mentioned 2.5 days as the average lifespan for a container. Is that enough for effective troubleshooting? Well, maybe in some development environments, but in production environments, probably not. Of course, containers are extremely independent, okay? Totally unaware of the general deployment context, okay? So, in fact, the only piece in your infrastructure that's aware of the deployment context is your execution environment. So, containers don't know, nor should they know, in what namespace they're running. But when we try to create a story from all the log data that we're collecting, when we try and correlate events, we need to somehow be able to add context to the log data. Of course, at any given time, you'll most likely be logging from a number of related containers, okay, distributed, located in different locations, etc. Just take a very basic example, the lamp stack. Anybody know what the lamp stack is here? All right. So you'll have one container running Apache, another one PHP, another one your MySQL database. But to be able to create your story, you'll need to be able to access each one of these data points. That's just a very basic example. And this distribution is not just horizontal, it's also vertical with different layers of information that Docker makes available for us that we can extract. So we all know the Docker logs command, right? Docker logs, container ID, container name, and we get the stdr and stdout output of the main container process. Fantastic. Docker stats command, Docker stats, container ID, container name, same thing, and we get some of those performance metrics that I mentioned before. Also fantastic. Our Docker daemon also records events, so any action we perform in our environment is recorded, kill, attach, etc. And taken together, again, these three types of information that Docker makes available can give us a very good picture of how our applications are performing. But you've got to remember something, okay? We're talking about a huge, huge amount of data sources. So if we take the Luxio environment, for example, we have about 200 Docker hosts running at any given time, each with multiple containers. Think about the amount of data generated. Think about tapping into each of these data sources. And this is without mentioning other issues that exist not only in a Docker environment, okay, in any environment, the different formats, okay, every application, every system, every environment generates logs that are built differently, okay. The timestamp field is the great example for that. Last time I checked, there are over 100 different ways that the timestamp field is formatted. And when you try and analyze data coming in from the different data sources, and each log's built differently, good luck with that. Accessing all of the logs, the issue of multi-line logs like Java exceptions, just as an example, etc. All huge challenges. So I think you're getting the basic idea here. So logging today, even despite all the existing tools, and some great logging tools out there, despite all of these tools, logging remains an art. Okay, whether ugly or not, you be the judge of that. But an art it is, instead of what we'd like it to be, which is a science, okay, with expected input, expected output, etc. So it's not all doom and gloom, of course. There's some great solutions. Well, not exactly great, but there are some solutions out there for us to use. Let's take a look at some of them. So data volumes, okay? Data volumes allow us to persist data in a way. We can map a local directory to a directory within a container. We could even map multiple containers to that same local directory, and that helps us build some kind of semblance of centralized logging, okay, to persist the logging data. But the issues start to occur when we start moving containers from host to host. And we've got to remember that we still need to think of a way to process these logs, parse them, and enhance them so we can get that context we said we needed to be able to correlate between the different data sources. Also, another thing to remember, we're only talking about Docker logs, okay? Only one type of information that I mentioned from the three available types of information. Another way to go are using logging forwarders or log routers. I'll talk about LogSpout later on, a very popular logging forwarder. And what they do is basically you can run these per host as a container. They'll attach themselves to all the containers running on your host and ship all the Docker logs to a defined endpoint, okay? So this helps you with the portability issue, but it still doesn't help you with the issue of, again, enhancing the logs. And we're only, again, talking about one type of information, Docker logs. So logging drivers is probably one of the more common solutions that we use for logging Docker. Introduced in version 1.12, if I'm not mistaken. Great built-in, relatively easy to use functionality, native functionality for Docker. And you can, when you run your container, you'll define a logging driver. This could be Splunk, it could be AWS CloudWatch or journald, etc. And basically, you could even do this per host, so you don't need to define the logging driver each time you run your container. And you'll get your Docker logs shipped to this third-party endpoint, okay? But of course, some gotchas that we've got to remember. So first of all, remember that Docker logs command that I like using. I don't know if you guys like using, but if we use a logging driver other than the default JSON file logging driver, we won't be able to use the Docker logs command. So that's one point to remember. Another one is persistency, okay? Or resiliency, more like it. So one thing you've got to keep in mind is that if the endpoint is down, if you're, for example, using syslog or journald as your endpoint, if that's down, then you might end up losing data. And again, those same disadvantages that I mentioned with the other solutions, the issue of parsing the data and enhancing it exists here as well. And of course, you've got a bunch of tools, SaaS platforms, paid solutions that you can use, including the one yours truly works for here. These will give you an easy-to-use solution, okay? There's some really good tools out there. You've got to remember that as your data grows, and data grows all the time, this is going to come at a cost. So it's something you've got to take into consideration. And also, most of the tools out there will only give you monitoring capabilities. So Docker will hook into your Docker stats and won't give you a solution for your Docker logs. So something to keep in mind. So this is why more and more companies are starting to use, for a while now, centralized logging. Okay, why? Well, because they help you overcome the challenges that I outlined before. Okay, they give you the tools to aggregate the data, collect the data from your different hosts and from your containers. They help you persist that data, store it in one centralized location, give you the tools to enhance those logs, process them, okay? So you can get that context that we said is important and crucial to be able to create a story of an event. And also they'll give you the analysis and visualization tools to actually dive through the data and analyze it. I like using the following two slides when describing the benefits of centralized logging. So in the old school logging, what we do is we SSH into a machine, perform some kind of fancy grep, and then hopefully scan the results and come across that one log message that is telling us that something is actually happening now in production. Well, good luck with that with 200 Docker hosts, each one with multiple containers. Impossible. In the Newschool logging, all we do is access Kibana. Yeah, okay, so I've simplified it a bit. It's not that simple, especially in big environments, but in essence, that is the meaning of using centralized logging. So when people talk about centralized logging these days, especially in the world of open source, they're talking about the Elk stack, Elasticsearch, Logstash, Kibanas, and like I said, it's been renamed these days as the Elastic Stack because of the advent of a new technology called Beats. It's not a family of log shippers. We'll talk about that soon. The Elk stack today is the world's most popular open source log analysis platform. Okay, you know what? It's probably the world's most popular log analysis, period. Forget open source. Used primarily for log analysis, but also extensively for search. But like I said, additional use cases. Just some statistics to put things into proportion. Elasticsearch is the second most downloaded open source technology today. Anybody know what number one is? Go on, wake up. Not Docker. The Linux kernel, okay? Elasticsearch is also the second most pulled image on the Docker hub. Anybody know what number one is? Nginx, okay? So impressive stats. Can't argue with those stats. And we're talking about over 100 million downloads for different components since 2010. If we did like a cross-cut analysis of the log analysis field, then we'd see about 15,000 companies using Splunk. Splunk is a great tool. They virtually invented the term centralized logging, but when compared with the amount of companies using the Elk stack, it's a drop in the sea, really, a drop in the sea. Why is Elk so popular? Well, for a number of reasons. First of all, for all the reasons we like using open source technology, okay? It's free, there's a community driving it, gives us a set of tools that we can then take from company to company as we advance in our career. It's relatively easy to set up, initially set up. Anybody in this room can get the Elk stack up and running and get a pipeline probably within an hour or two. What happens later on when your data grows, when your environment grows, when your pipelines get more complex, that's another issue, okay? But the initial setup just to get it up and running is very, very simple. And we're talking about blazing fast results when searching on Elasticsearch. Across millions of documents, you're going to get really, really fast results. So what does the classic Elk stack pipeline look like? So at the center of the stack, the heart of the stack, if you like, is Elasticsearch. Okay, Elasticsearch is where your data resides, is indexed and stored. It's a full-text search and analysis engine based on Apache Lucene, completely open source, of course. Boasts an extensive REST API. It's one of the main features that people like using Elasticsearch, so you can easily interact and query with the data. Sorry about that. Collecting the data from the different data sources is Logstash. Logstash is basically the stack's workhorse, doing a lot of processing work, not just collecting the data and sending it into Elasticsearch, but also performing those data enhancements, okay, to the data, dropping unnecessary data, adding stuff, enriching some of the fields, however you like to define the processing. And you've got Kibana, of course, which is the UI's pretty face, okay, basically a tool for analyzing and visualizing the data. So you'll have Logstash pulling the data from your hosts and from your containers, processing your logs, pushing them into Elasticsearch, and then you'll use Kibana to analyze the data. Now, this is just the simple, if you like, a vanilla architecture of what the Elk stack would look like, but there's different variations, and like I said, as your environment grows, you'll most likely use a different variation of an architecture. For example, you might use a different kind of log shipper, perhaps a more lightweight shipper to install on each host. So I mentioned the Beats family of shippers before, but you might use FluentD as well. You might put into place some kind of buffering mechanism in between Logstash and Elasticsearch to create a more resilient data pipeline to handle bursts more effectively, for example. And you might install Nginx in front of Kibana to add authentication, authorization, etc. But that is the classic pipeline. That's what it looks like. So how does one get all of this up and running? So, of course, the topic of setting up a production environment with complex pipelines, resilient pipelines is a topic for an entire workshop, but I will try and provide some basic tips and best practices to those of you who want to get started. Of course, the first step is to install the stack. Okay, there are various ways of doing this. You can use Elastic's packages, you can use Docker, install it locally, remotely, whatever you want to do. This I like using, especially for development and testing purposes, I like using this Docker image. This is by far the most popular Docker image for the Elk stack. Okay, last time I checked was over a couple of million pulls from the Docker Hub. What it does is use Docker Compose, and it results in 3 parallel containers, one for Elasticsearch, one for Logstash, one for Kibana. You've got basic configuration pipelines up and running. You'll have port forwarding all set up for you. You'll have a data volume for persisting Elasticsearch data. So it's all set up for you. Rich running options, great documentation, well recommended. That's the easy part, installing the stack. Now you've got to understand how you want to collect the data from your containers and from your hosts. So I'm going to outline a couple of methods that you might use. Now, remember the logging drivers? So the default behavior in Docker, as you probably well know, is to log your stdr and stdout output to a JSON file on your host. This is the JSON file logging driver. So it makes sense, at least as you start out, building your pipelines, to use FileBeat to collect those JSON files and push them into Logstash or directly into Elasticsearch. FileBeat, like I said, belongs to the family of Beats, log shippers, different log shippers for different purposes. FileBeat specifically, as its name implies, basically tracks specific files and ships them to a defined output that you define. You'll have 2 main configuration areas in your FileBeat configuration file. The first one defines where you want to, which files you want to track. So here's an example. This is basically the default location for your container logs. You can use this wildcard configuration basically to ship all your container logs into the Elk stack. And then in the output section, so you define where you want to send the data to. Usually this will be to Logstash, okay? Because that's where all the processing takes place, but you can ship it directly into Elasticsearch if you like. Right. So FileBeat's one way to go. You could use logging drivers, okay? In the context of shipping to the Elk stack, you could use the syslog logging driver, It probably makes the most sense. So when running your container, you'll define your syslog instance. What you do need to remember is that on the Logstash end of things, you'll need to define the syslog input plugin to pull data from your syslog instance. Another way to go is logspout. So remember, one of those logging forwarders, and it'll attach itself to all the containers running on your host. It'll run as a very lightweight container. I think it's just about 15 megabyte in size. And it'll ship all your container logs running on that host to a defined endpoint. Okay, and again, in the context of the elk stack, it makes sense to send to the syslog instance. You can ship directly to Logstash, but then it requires recompiling and additional configurations, and I wouldn't recommend it. Okay, so those are 3 methods of collecting the data from your containers and from your hosts. The crucial step in building an elk-based pipeline is configuring Logstash, okay? As powerful a tool as it is, it's also a complicated beast to tame, okay? Because of the processing that it involves, because of the different configuration options, because of the plugins that you can use. But basically, your Logstash configuration file contains 3 main sections. In the first section, you define where you're collecting the data from. So in this example, like I said, we're using a syslog input plugin. But if you're using FileBeat to collect the data, you'd use the Beats input plugin, with a variety of different plugins available to use. I'll go over the filter plugin in the next slide, but this third section is where you want to send the data to from Logstash. Usually this will be, of course, your Elasticsearch instance, but if you're using some kind of buffering mechanism, you might want to define, I don't know, Kafka instance or Redis, etc. So back to the mid-section in your Logstash configuration file, the filter section. This is where the magic takes place, if it's configured correctly and if everything works as expected. And this is where basically you'll massage your log data. This is where you'll add context to your logs. This is a simple example of using 3 filter plugins to process Apache access logs. So we're using a grok filter plugin to map the different fields within the in the message field. We're using the date filter to define our timestamp field. And we're using the GeoIP filter plugin to basically enrich the client IP field. Okay, and the result of this processing will basically add geographical information, geographical fields based on the IP, the value entered for the client IP field. So you're going to run Logstash. I've got to mention security as an additional step to consider. I'm not sure if you guys heard about this, but last year there was a huge ransomware attack mounted against insecure Elasticsearch clusters, mainly deployed on AWS. And basically anybody with one of these insecure clusters tried to query their data, got this unpleasant message. Extremely unpleasant, especially with the prices of Bitcoin right now. But the good news is that some basic steps that you can take to make sure your Elasticsearch is secure. First, primarily, you've got your network host field in your Elasticsearch configuration file. All you have to do is bind to localhost or private IP. That should be enough. You can, of course, change the default ports, place a proxy in front of Kibana, like I mentioned, Nginx, and that should do the job. And the end result, of course, after you running all your containers, or if you install the elk stack using Docker, but as you run your data pipeline, the data will start flowing. You'll start querying your data, visualizing it, building these beautiful dashboards. Now, up until now, we talked about one element of the challenge of logging Docker, okay? What we've got to remember that multiply X slide? So the end result of building this kind of pipeline from your Docker environment into the elk stack are thousands and thousands of log messages. So the big question is, how do we sift through that data? How do we actually go through that data and find logs that actually signify that something is happening? Okay? And this is the famous needle in the haystack syndrome. Okay, so yeah, we can use Kibana. Okay, that's what Kibana's there for. We can use Lucene-based queries to query Elasticsearch and hopefully find specific log messages. But again, you've got to understand that we're talking about a huge amount of data. And this is where the machine learning part comes into the picture. Okay, now yes, there's a huge buzz around machine learning. You've got to remember that also, in a way, Docker was a buzzword a couple of years ago. So it's true, okay? Machine learning, deep learning, AI, all of these terms have been thrown around way too many times. But the truth is that companies are already implementing machine learning, not only in their products, but also as part of their internal technology stacks. So at this point, what I'd like to do is do a short demo and show you what I mean. So what you're looking at now is the Logs.io user interface. But if anybody of you know Kibana 5, then you'll see it's basically the same. Anybody use Kibana 5 here? Okay, great. So it's basically the same, but we've added a couple of stuff on top of it. You'll have your main display area here showing the different logs coming into the system. And on the left, you have the list of fields as processed by Logstash and as mapped in Elasticsearch. Now, in this case, what I'm doing is I'm using a Docker log collector that we created. Okay, acts like similar to Logspout, so it runs as a container and attaches itself to all the containers running per host. But its uniqueness lies in the fact that it ships not only container logs, but also Docker stats and also daemon events. So what I'm going to do, I'm just going to open a saved search to show only Docker logs. So if you guys were using any of the methods that I described before, so any of the logging drivers or Logspout, for example, this is what you'd see, basically, okay? So you've got your logs coming in from your different containers, and on the left, you've got your list of fields. And what you do is you'd start entering some kind of queries to search for specific information. Of course, Kibana is renowned for its visualization capabilities. So you, just as an example, you can hit on one of these fields, click Visualize. Not very interesting. Bit more interesting, showing different logs coming from the different containers. But you can, of course, slice and dice the information in any way you want. So, for example, you can create some kind of line chart. We'll base it on Docker logs. And this is going to give us a depiction of the different logs coming in from the different containers over time. So you can already see the importance of the processing step in Logstash, because that'll give you the fields that you can use for analyzing and visualizing the data. And once you've got all your visualizations up and running, combine them into a beautiful dashboard. And if it looks familiar, you're not mistaken. It's the same dashboard you saw before in the slides. But what I'm going to do is I'm going to go back to the Discover tab. And what I'm going to do is, again, this is just from today, okay? I'm going to take a look at the last week. I'm going to enter a new search. And you can see we've got over 200,000 events, okay, which isn't big, okay, per se, but it's enough to convey the message here. So how do we go through all of that information and find critical events? So what we can see here suddenly are two events here that are flagged. Okay, we call these insights. I'm going to click one of these events, and all of the log data over the past 7 days is filtered accordingly. I'm going to open one of these log messages. Then I get a description of what happened. Then I get a link to some resources on the web discussing this very same log message, so you can start understanding the event and start troubleshooting it. So what's important to understand is what's happening behind the scenes. What's happening behind the scenes is a machine learning mechanism that we've employed. It's basically scanned through all of our log data, found a correlation between a Redis log message and a discussion happening on Stack Overflow. And it's flagging that event for us. Might indicate that something critical is happening that we need to take a look at. So how does one go about designing this kind of system? How does one go about implementing this kind of system? So the different types of machine learning, there's supervised machine learning, unsupervised machine learning. In this case, what we're using supervised machine learning, okay? And in supervised machine learning, what we're doing is we're training a model by example, okay? We're feeding it samples and we're giving it the correct answer to each sample. And what we're hoping is at the end of the process, when the system or the model sees a sample that it hasn't seen before, it'll give us the correct answer. All right? And in the context of logging, and what we're seeing here is what we're doing is we're using log messages as the samples. We're giving it the right answer to one simple question, and that is this log important? Do we need to take a look at this log message or not? So how do we implement this kind of system? Again, two main steps. The first step is collecting our samples, all right, and labeling them. So collecting the samples for a log analysis company is pretty trivial. It's what we do. It's our business. We collect log data from our customers. The process of labeling is a bit more complex. In the process of labeling, what we're doing is we're attributing different tags to different logs. All right, we're labeling different logs. And how, just as an example for a label could be a log message containing specific syntax. Or it could be a log message that we recognized was opened more than X number of times. Okay, it could be a log message that we've seen discussed on Stack Overflow and that's received specific scoring on Stack Overflow. Okay, these all are basically calculated into an algorithm which is used to train a classifier. Classifier is basically some kind of mathematical formula, mathematical representation for the logs used basically to give us the answer to that question, whether a log is important, yes or no. As far as the infrastructure involved, we're talking about a lot of computation power used, which is probably one of the disadvantages of the system. The costs of implementing this kind of solution. In our case, we're using dozens of EMR instances with Hadoop and Spark doing a lot of the heavy lifting. So circling back to our Disney movie, I owe you an answer. How did our guys finally come across that one log message? So the answer is pretty obvious now. Basically, the system managed to identify this discussion on server fault. You're more than welcome to take a look at it. And basically, time to resolution from then on was an issue of a couple of hours. Time for some summaries. When people ask me what's the best way to log Docker, I usually smile. Not because I'm trying to be cruel or funny. I'm never funny. It's simply because there is no silver bullet. There is no out-of-the-box solution. It depends a lot, of course, like anything in software development, depends on your requirements, depends on your needs. Are you interested only in Docker logs? Do you also want the other types of information that Docker makes available? Are you insisting on going on an open source solution, or are you willing to pay for a SaaS platform? Okay, these are type of considerations that we need to think about. And it's my feeling at least that until Docker doesn't take logging to an entirely different level, it's just simply up to us to figure out and hack our own solution. So we talked about two main challenges involved in logging Docker. One is the intrinsic nature of Docker, the transiency, the difficulty of tapping into the different data sources, adding context to the logs, dealing with that distribution issue, persisting the data, okay? And the challenge number two is actually gaining insight from the data. So while the ELK stack is probably perfectly poised to tackle challenge number one, it's machine learning that'll help us with challenge number two. Just some extras here to end the presentation. Got a couple of interesting projects on our GitHub repository, okay? Not just Docker related, but also ELK related. We've got some Dockers that do Elasticsearch performance monitoring, either using Graphite or other kind of databases. We open sourced, just this week, we open sourced two main projects in our architecture. One is Apollo. Apollo is basically a continuous deployment tool for deploying on Kubernetes. And Sawmill. Sawmill is a Java library, okay, for processing data, processing JSON documents. And it's what we've employed in our architecture to replace Logstash because of all the issues that we encountered with Logstash. So basically, Sawmill is doing a lot of, well, all of the processing in all our ingestion pipelines. And like I said, a couple of other interesting projects, including the Docker log collector that I mentioned that I used for the demo. A bunch of useful information on our blog. You're more than welcome to visit. Again, encompassing a wide array of different topics, Docker, ELK stack, DevOps stuff. more than welcome to visit. Elastic documentation is also key. Okay, they've got great instructions there for helping you set out building your pipelines. We've got a Slack team, so if you want to ask any questions about the Elk stack, more than welcome to join. You just enter that link, and I'll send you an invite, and you can join the team. So feedback, questions, whatever you want. That's about it, guys. Questions? Yeah. That's you.
I was wondering about if you can provide insight on scenarios when we should or maybe may avoid using ELK, maybe computers out of our main business logic or network controllers, or maybe there are scenarios when we don't want to go to a full analysis logging architecture. Do you have few
well, let's try and think about the alternatives here. Using Amazon services?
Maybe even something more old school like Collect D or old.
So again, the Elk stack is, like I said, its main added value is the centralized logging. So it will help you aggregate from different data sources and match between your Collect D data, perhaps with other data sources, okay? Because sometimes your Collect D information was simply not enough to be able to get that general picture of how your environment's performing. I'm sure there are use cases where the Elk stack is not a viable solution, okay? It'll depend, like I said, it depends on your needs and your requirements.
Okay, maybe the second one, really short. Do you know any free software project using machine learning over ELK currently?
Machine learning on ELK?
Yeah.
So Elastic have done a bit of machine learning. It's completely different to what we do, but that's also it's part of XPack. So XPack is the added plugin that you can install on top of Elasticsearch, Kibana, and Logstash. So they have some kind of more anomaly detection style machine learning. Other than that, I haven't encountered anything else. Maybe someone else here.
I was thinking about the project like blockchains based that are main distributed in all the nodes. So do you recommend a solution like ELK for blockchain projects in that base?
I really don't know how to answer that. I'm total beginner in the field of blockchain. Interesting, really interesting question. Need to look into it. Food.